Hi everyone. Today we're going to learn a theorem about inequalities in one triangle. And inequalities are of course less than or greater than, and that's what we're going to talk about today, is how to know which angles are less than other angles, which angles are greater than other angles, and then same thing with the sides, which ones are bigger and which ones are smaller. Now these theorems all have to do with opposites. And we've used that word before. I used that word when I gave you the definition of the word hypotenuse. I said in a right triangle, the hypotenuse is always opposite the right angle. Well, we're going to start thinking of all three sides and all three angles of a triangle in opposite pairs. So basically when I say opposite, what I mean visually is opposites on the other side of the triangle. So if the angle's over here on the right, we're talking about the side on the left. Or if the side is on the bottom, we're talking about the angle on the top. But more specifically, it's the one that's not connected. An angle is made up of two sides of a triangle. The opposite side is the one that's not used to make the angle. So we have a triangle behind me. Let me get rid of me. In this picture, I said angle A, which is right here, is opposite side BC, which is right here. That's what we mean to be opposite. And then angle B here is opposite side AC, right here. Color that one in green. And then finally, angle C, the last one, 1, 2, 3, is opposite from side AB down here. So I kind of made it match up in color. Red is opposite from red, green from green, blue from blue. But it all comes in pairs. Each side has an opposite angle, each angle has an opposite side. Okay, so here's our actual theorem. What it says is once you notice those opposite pairs, they match up by size. So the smallest of the three angles is always opposite the smallest of the three sides. The biggest is opposite the biggest. And then of course that just leaves the middle ones. So they pair up. Smallest pairs with smallest, middle with middle, biggest with biggest. So for our first example today, I gave you guys a right triangle, and remember, it doesn't have to be a right triangle for this. It is for this example, but this actually works for any triangle. And I said, what is the smallest angle in triangle PQR, and what is the largest? Two different questions. So let's start with the smallest. If I want to find the smallest angle, now notice none of them are marked except for the right angle. I know the right angle is a right angle, but I don't know what angle P is, and I don't know what angle R is. If I want to find the smallest angle, I look and I notice I do know all of the sides. So I find the smallest side, and I say it needs to be opposite the smallest angle. So the smallest angle is angle R. Now let's do the same thing for the largest, because I also asked you to find the largest angle. So the largest angle, I'm going to find the largest side, which is the 5. I'm going to go opposite from it, and the answer is angle Q. All right, so very simple and straightforward. I didn't ask you about the middle one. If you find the smallest and you find the largest, the middles are just left over. But the middle side, the 4, is RQ, so the middle angle would be angle P. Okay, let's do this example here. I'm going to flip the question on you. Instead of giving you the sides and asking for the angles, I'm going to give you the angles and ask for the sides. So I said, what is the smallest side in angle ABC? And what is the biggest side? Now we're not ready to answer yet because I don't know what angle A is. But what I do know is that the three angles of a triangle always add up to 180. That was one of our theorems from earlier this year. So if I want to find angle A, what I can do is take the two I know and add them up. I'm going to do 68 plus 29. That would be 1797. Now I'm going to subtract that from 180, and what I get is 83. So with a tiny bit of work, I figured out that angle A is 83 degrees. Now I'm ready to actually answer the question. So for the smallest side, I'm going to find the smallest angle. The smallest one is the 29. And I'm going to go opposite from it. And it's going to be that side right there, which would be line segment AB. Remember, when you're naming a side of a triangle, a side is a line segment, so you do 2 letters. Line segment AB. Now for the largest, I now know that the biggest angle is the 83. I didn't know that right off the bat from looking at the question originally. I wasn't sure if it was going to be bigger than 68 or not. But now that I know that the 83 is the biggest, I look over here and I see that side BC must be the largest side. So that's basically what we're doing today. We're taking triangles, we're comparing sides and angles. We're saying, okay, if I know what the smallest angle of a triangle is, opposite has to be the smallest side. Or same with backwards. If I know what the smallest side is, opposite is the smallest angle. Same works with biggest, same works with middle.